Chlorine disinfection. So this video, the three after, all having to do with chlorine disinfection. There is a disinfection alternatives mixed in there too. But chlorine is the most hands down used way to disinfect water. One of the reasons why is because, well, there's several reasons why. It's readily available. There's a lot of it. We have multiple suppliers that can provide it to us. Chlorine, so it's readily available. It's easily applied. And at very low doses, it's very effective. So it doesn't take much chlorine to disinfect the water. Okay, so the thing is there are a lot of drawbacks too. There's advantages and disadvantages to everything with chlorine. It's the toxicity. Chlorine gas is very dangerous. You want to limit your exposure to chlorine. Chlorine is not something that you can get used to, right? It's not something that you can build up an immunity to or a resistance to. It's something that if you're inhaling large amounts of chlorine because you think it's cool, because you think, oh yeah, I can deal with this, it's no big deal, and you do it day after day, year after year, that injury to your body will just continue to get worse and worse. You don't heal from it. So this is not something to take lightly. Let's go to your study guides. Question 1. Chlorine storage rooms should, and we'll start over here, just like always.
I'm not finding it. Maybe I'm in the wrong.
Okay. All right.
Pretty good. At the end.
Yep, question number 1.
Okay. Chlorine storage rooms should C, have lights and fans on the inside and wired to the same switch.
Very good. So there's a lot of things about chlorine rooms that are required. It's in the study guides, the study material. And you know, when it comes to my study guides, I spend a lot of time on these. I give you all the information I can give you. I double check it, triple check it, just to make sure I'm giving you the best information, the most accurate information. I talk to a lot of people who take state certification exams, not just here in Arizona, but in other states also. And you'd be surprised at how similar a lot of these other states are when it comes to Arizona and the different grades. With that said, there are a lot of different requirements for a chlorine room, and we're going to go through some of them today. But read that study material, understand it very well. You know, my program is not, what I'm trying to do is not give you the answers to the state exam that we're all familiar with here in Arizona. This distribution program has been designed to prep people for grade 1 and grade 2 distribution here in Arizona. There's grade 3 and grade 4 material in here, and I do cover more subject matter than you would find on your exams. I want you to understand the why. I don't want to just give you the answers to what I think is on the exam, because the exams change too. So there's no program that's going to give you all the answers. It's going to change, and I've seen it myself in the exams that I've taken. So number 2, free chlorine combines with water to form
Hypochlorite acid and hypochlorite ion.
A. The hypochlorous acid and hypochlorite ion. Very good. Hypochlorous acid is the disinfecting agent. It's not the last time you're ever going to hear me say that. Hypochlorous acid is the disinfecting agent. It's most effective. Number 3, when reading a float in a rotometer, rotometer, different people say it different ways. When reading a float in a rotometer, look at the blank of the float.
That's gonna be on the whitest part.
The whitest part of the float. Now the float could be, now just to diagram it out, a rotometer could be basically a cylinder. It has graduations. The unit of measure is in
Milligrams.
for a chlorine tank, pounds per day.
Oh, pound.
Yep. There's dual purpose. Some of them you'll have the flow in gallons per minute or liters per minute, and it might be just a cylinder. It might also be a cone or have just a very slight gradual taper to it going down. It will also have graduations. The float could be a ball, or it could be a bullet-shaped float, which basically looks like a bullet. Now, if it's a ball in a rotometer, you would measure at the widest part of the ball, so right here in the center. If it's a bullet-shaped float, you want to measure right at the top. Okay? Now, typically in these certification exams, it's saying it's a ball. So it's the widest part of the ball, or the widest part of the float. All right? I love this thing. Number 4. A rotometer is used to measure the flow rate of
C, gases and liquids.
gases and liquids. It could be used for gases or liquids. Very good. Number 5. As the temperature of the water decreases, the disinfecting action of chlorine is
C, less effective.
less effective. So water temperature and chlorine. And this is true for a lot of other chemicals that we use in the water wastewater industry. The colder the water is, the more it reduces the reaction time of that chemical. If you raise the temperature of the water, if it's warmer, the reaction time is quicker, faster. It's more reactive.
Isn't that because the water's colder, it's more dense?
Yes. Yep. A lot of these chemicals have been engineered to be most effective around 68 degrees. 68, 72 degrees. So if the water's 50 degrees, you're gonna see that it's gonna take more chlorine to disinfect the water because the reaction rate is a lot slower. When chlorine hits the water, it makes hypochlorous acid. Hypochlorous acid. And the hypochlorite ion, it splits off, and it depends on temperature, pH, how effective it is. Okay. Number 6, chlorine in its dry form is
B, calcium.
calcium hypochlorite. That's the dry form. Dry form of chlorine, calcium hypochlorite. It's 65 to 70% chlorine. The rest is calcium. Calcium's not a disinfectant. It's just the carrier agent. It's just the means by which we deliver the chlorine or transport the chlorine. Number 7, milligrams per liter is the same as, George,
C, ppm.
ppm, parts per million. Number 8, a free chlorine residual of blank must be maintained throughout the distribution system and to the most remote point of the distribution system.
That's gonna be C, 0.02 parts per million.
Say that again.
Oh, sorry, 0.2.
0.2 parts per million. Very good. Because that can be confusing.
Yeah.
So that's the minimum. That's the minimum chlorine residual we want throughout our distribution system and all the way to the furthest point of the distribution system, the last and the very end of the distribution system. If we have a 0.2 part per million chlorine residual, and this is a free chlorine residual, then we can be reasonably confident or assured the water is safe. Okay? Now, there's reasons why. So chlorine is very good at killing off bacteria and viruses and parasites, right? And some of these are disease causing. Now, in our industry, when we disinfect the water, instead of testing for all those things, which can take a lot of time and money, instead, we have found the coliform group of bacteria is very robust. It's hard to kill. It's known for sneaking past other disinfection processes. However, if we give it a little bit of chlorine and enough contact time, that is enough time for the chlorine to react with it, chlorine will destroy, deactivate, neutralize coliform bacteria. So if we are able to neutralize and kill off the coliform bacteria to where it doesn't show up in our samples when they get tested, then we feel confident that the pathogenic organisms, bacteria, viruses, parasites, have been killed off, neutralized, deactivated. Okay? Coliform bacteria is typically not even harmful to us. It's found in nature. It's found in roots and leaves and trees and things like that. But it's just a very robust bacteria. It's very strong. It's hard to kill. So, and it's easy to test for. It's easy to find. So when we send our samples off to the lab every day, they're looking to see if we're coliform positive. And then if we are, then there's steps that happen after that, which is another video for another time. So 0.2 parts per million or 0.2 milligrams per liter. Number 9, when a chlorine cylinder or container is changed, a new gasket should be used.
A, every time.
Every time. So the gasket, and this is a chlorine cylinder, so this is a gas chlorinator. So what this gasket is the connection between the tank and the feed line. This is a lead gasket. It's soft metal. So when you make the connection, it perforates the lead and creates a seal, which is what a gasket does, right? It helps you seal and keeps the unit from leaking. Doesn't matter if it's on your garden hose or on a gas chlorinator. So this lead gasket can only be used the one time. It has to be a brand new lead gasket especially because of the perforation, right? The perforation into the lead, if you try to use it a second time, that perforation may interact with the new connection and chlorine could escape. Okay. Number 10, which of the following has the greatest disinfection potential?
A, HOCI, hypochlorous acid.
HOCl.
Oh, there's like an I.
What? Is it I?
Oh, it's an L.
Yeah. Hypochlorous acid. Yeah, HOCl. What am I thinking? Sometimes I have a brain fart. I see this stuff all the time and it gets mixed up. It's like, as the older I get, the more I realize I can spell. I'm a pretty decent speller. Sometimes I forget how to spell simple words like Brian.
I didn't have my glasses on, so that was my fault.
It's all right. Number 11, a gas chlorinator rotometer reading is
C, pounds per day.
pounds per day. Pounds per day. Number 12, when shutting down a gas chlorinator system, which valve should be closed first
A,
on the system?
A, the chlorine feed valve on the cylinder.
Chlorine feed valve on the cylinder. So where the gas is getting fed into the water supply, it's basically as the water is running past, it's creating a vacuum through the venturi. So it's pulling gas out of the feed line. So if we close that valve first, the chlorine on the tank, which is one full turn,
Yeah.
one full turn will close the tank. Then it allows that gas to be pulled out, cleans out that feed line. Number 13. What is the typical strength of calcium hypochlorite, i.e. available chlorine range?
It's gonna be 65 to 70%. C.
C, 65 to 70%. Now, and we brought this up before, so for those of you who are watching my videos who don't know me personally, whenever I train my employees and we're talking about chlorine, especially calcium hypochlorite, we have a procedure on this crew. When we open a bucket of calcium hypochlorite, we take the bucket, if it's brand new, we break the seal on it and spin the lid just enough, not to remove it, but just to make sure that it's loose on top of the bucket. And then we check the wind direction. Which way is the wind blowing? Well, if the wind is blowing at me from this direction and it's going down that way, and I have the bucket right here, first I'm going to look downwind. I'm going to see if there's anybody downwind of me, because I don't want to open that bucket and have them hit with a bunch of chlorine gas. I'm not going to stand downwind of the bucket and open the lid. I'm not going to open the lid of the bucket with my face right over it, because the headspace between the chlorine, the calcium hypochlorite that's in the bucket, and the lid of the bucket is filled with 100% chlorine gas. And a little bit of chlorine gas goes a long way. It takes a little bit of chlorine gas to really mess up your world. Because when chlorine, even chlorine gas, interacts with the moisture in your eyes, in your sinuses, in your throat, in your lungs, it can do immediate damage. So what we do, after we check the downwind to see that there's nobody there that's going to be affected, take the lid of the bucket, turn around and walk away as you're taking it off and go upwind. Give it a few minutes to air out. There's nothing you need to do immediately that requires you to have your face in there. Give it a couple of minutes, let it air out a little bit. It's still pretty intense, but you'll be able to work with it. Wear your PPE, Brian. Number 14, small gaseous chlorine leaks in and around the chlorinator can be detected using commercial strength
Ammonia.
ammonia. Very good. And this ammonia is in a bottle. It's a bottle that you can squeeze very easily. It has a little
There's a little,
yeah,
like
little spout on it.
Yeah.
There's a name for it.
I forget the name.
Not thinking
but
what
it
that
does
is right
create
now.
a white cloud.
But it just takes, so you fill that container about halfway, halfway. You want a lot of ammonia gas in there. So when you are working with the chlorinator, you'll squeeze that bottle around points where, around the chlorinator, around the valve, around the connections, around the fittings, and you're looking for a white cloud or vapor. If that white cloud or vapor is present, then you have a chlorine leak. Ammonia reacts with chlorine and creates that white cloud. It's also very, very poisonous fumes, so you don't want to breathe it.
So you're always wearing PPE.
You're always wearing PPE when you're dealing with the chlorinator. If you're not, then whoever is supervising you should stop everything, take you to the side, and retrain you. And that's no joke. And that goes for anybody. In the utility we work in, it doesn't matter who you are. It doesn't matter if you're supervisor, somebody in charge of a crew, or if you're on a crew. If you see somebody doing something dangerous, first of all, if you're not sure if it's dangerous or not, if there's a risk, but you're uncomfortable with it, then stop everything. Stop the job, stop everything, and just say, hey, look, I'm uncomfortable with this. Are we doing this the right way? Let's look at our job safety analysis or our job hazard analysis. Let's make sure that we're doing things the right way, that everybody has the proper PPE. Well, look at that. There's a first.
Mm-hmm.
You can speak clearly and I can't.
Yeah.
Mr. One Syllable. Sorry. So
You're building
no,
it up.
I'm not
Keep
sorry to
going.
you. I was apologizing to him. Yeah, you gotta make sure you're wearing your PPE. Make sure you're taking this job serious. Our job is so dangerous. Working in the water wastewater industry is an incredibly dangerous job, and people don't even realize it who've been working in it for years how dangerous it is. But you gotta take it serious. Number 15. Which is the most effective disinfectant for inactivating bacteria? Excuse me. Yeah, Dave.
B, hypochlorous acid.
Hypochlorous acid. That's the one that's fun to pronounce. Hypochlorous acid is the disinfecting agent. It's the most efficient, most effective disinfecting agent. Number 16. Which device creates the vacuum required to operate the chlorinator? Let's go over here.
That's going to be A, the injector.
The injector. Number 17, what would be the result of HTH encountering oil, rags, or paper?
B, may ignite into flames.
May ignite into flames. So anywhere that we're storing chlorine of any product, whether it's chlorine gas, HTH, which is calcium hypochlorite, the powdered form of chlorine, or sodium hypochlorite, the liquid bleach form of chlorine. Wherever we're storing these chlorine products, nothing else gets stored with it. Just the chlorine and the containers they're in. We don't want things like oil, rags, and paper coming in contact. HTH, again, is very, very reactive. It could cause a fire. So we want to be especially careful. Number 18, when feeding gaseous chlorine, what is the likely problem if the rotometer indicates no flow and the vacuum gauge on the feeder is 30?
That's gonna be a closed valve on the inlet of the feeder.
A closed valve on the inlet of the feeder. So D?
D, yes.
Very good. Everybody agrees?
I'm so smart. Stop.
Pathogenic organisms, diseases, found in water include
D, all of the above.
all the above. Bacteria such as dysentery, typhoid, cholera. Does that sound familiar?
Cholera, you mean?
Cholera?
Is it cholera or cholera?
It's cholera.
Oh wow, I've been saying it wrong this whole time. Okay, you could go ahead and take back your statement then.
Take it back. No, now it's reinforced.
Oh, okay.
Thanks for reinforcing it again.
All right.
You should see his beard, by the way. I don't even call it a beard. Viruses such as hepatitis, polio, and enterovirus. How do you pronounce this?
I call it just a burp, so.
Oh.
Take that.
That was good. That was good. Parasites such as amoeba, giardias, and cryptosporidium.
I'm not even gonna attempt that one.
Yeah, I should have had you
Yeah.
pronounce it before I did. Number 20, what are the first steps to shut down a chlorinator? Number 20, what is the first steps to shut down a chlorinator?
B, closed tank, allow line to clear.
Very good. Number 21, the best way to prevent loss of prime is to design a pump installation with
C, positive suction head.
positive suction head. We've gone over that a few times, but when we have a hypochlorinator, took me a second, it's been a long day. When we have a hypochlorinator that's using liquid bleach to feed that bleach solution into the water stream for disinfection, typically we have two pumps. Ideally, it's two diaphragm pumps. These are positive displacement pumps that have check valves on the suction side, check valves on the discharge side. So as that diaphragm is going back and forth, it's a positive displacement pump, so it's getting an equal amount or the same amount with each dose, with each revolution, with each stroke of the piston, if it's a piston pump. So it's a precise amount with each stroke. Okay, so we'll have two of those pumps, one in duty, one in standby. You always want to have two. Now I'm sure there are some systems that are very, very small, that flow very, very little water. They don't have a lot of money, and they have one pump that's in use, and hopefully they have one on the shelf. Because if that pump goes down, they've got to, if they have to replace it, they need to replace it pretty quickly. And it can be done very quickly. It can be done within a couple hours. You know, when I worked at a certain plant back when I first started in this industry, we had two pumps. We had a hypochlorinator feeding bleach solution. We had the duty and the standby. And when we would take the one in duty, when we would take it offline, we would first start the standby pump or the backup pump. We would start that up, get it going, make sure it was feeding right, shut down the duty pump, which automatically made the second pump the duty pump. And we would lock out, tag out, using PPE, and with all the proper PPE, we would disassemble that pump with just our hands. And that's the feed lines, that's the thrust plate holding the diaphragm. So we could take these backflow, the checks apart, take everything apart by hand. It was that simple. And it didn't take very long to flush everything out. If there was any buildup, we would use a little bit of vinegar if it was necessary. Usually it wasn't, because we did it probably more often than it should have been done. We probably did it every couple hundred hours of operation. But that's okay. We can do it a little more often, and it kept us fresh, you know, so. But we did make sure that that installation was built with positive suction head. That means the day tanks that were holding the chlorine solution, one was attached to each pump. The duty pump, the valves were open. On the standby pump, or the spare pump, all the feed valves were closed and the lines were cleared of any bleach solution. That way it wasn't just sitting in there wearing things out, because chlorine reacts with everything and eventually it'll kill it. So, but yeah, we had positive suction head, so gravity took the chlorine to the pump. The pump didn't have to pump the chlorine from a lower level up to it. 21, under which circumstances may a positive displacement pump be operated against a closed discharge valve?
The answer is C. Never, ever.
Never, ever. There's never a good reason to operate a positive displacement pump against a closed discharge valve. It just creates too much pressure. Could damage the pump, the valve, the whole system, cause leaks. It's a nightmare. Basically, it's apocalyptic. Apocalyptic. Starting to sound like Brian. 23, what is the most common use today for a positive displacement pump?
B, chemical feed pump.
Chemical feed pumps. So not only does this positive displacement pumps, not only do we use it to deliver chlorine, bleach, or a bleach solution that we make using water and HTH, or calcium hypochlorite, but it's used to feed other chemicals into the water treatment process or the wastewater treatment process. Okay, used all throughout the industry, all different parts. And one of the main reasons why is because it's a precise dose with each stroke of the piston. 24, what is the purpose of a hypochlorinator? What is the purpose of a hypochlorinator, Brian?
Chlorinate water for disinfection.
Chlorinate water for disinfection.
Excuse me,
Yeah.
isn't a hypochlorinator for feeding liquid bleach?
Yeah. What did we say?
It says chlorinate water for disinfection, doesn't really
Yeah.
specify which.
No, yeah.
it does.
So of these choices, that was the best
Oh,
one.
okay,
But yeah, it's for feeding a chlorine bleach
I
solution.
apologize.
Oh, no, that's okay.
Okay.
Because there's probably somebody else, if anybody ever watches these videos, somebody else is gonna have the same question.
Alright.
That's why it's okay
Okay.
to ask questions. It's okay to interrupt rudely. I don't mind. Oh, that was fun. You didn't hear what I said. I said it's okay to interrupt rudely. I don't mind.
Okay.
Number 25, when should a hypochlorinator undergo preventive maintenance?
A, after 300 hours of operation.
After 300 hours of operation, that's the best answer. So 300 hours of operation, or what the manufacturer recommends. That's always the key. If you ever see a question like this, is when should PMs be done on this equipment? If one of the choices is whatever the manufacturer recommends, that's the correct answer. Because it always falls back to that. If you look at your plant O&M, operation and maintenance manual, if you look at the O&M for a piece of equipment, they will tell you, this is when we want you to perform preventive maintenance on this equipment. But as a rule of thumb, 300 hours. And that was the rule where I was when I first started in the industry. I worked at a wastewater plant for a while, and then eventually I went over to a water plant, and I was the lead operator there for a year. Then they wanted me back at the wastewater plant, which I really loved it. I thought I was gonna do wastewater treatment my entire career. And then I started doing field ops and
Way better.
way better. And that's it. Guys, thank you for your time.
Hey,